Assalamualaikum and good afternoon, everyone. I hope everyone is safe due to the flood, and I hope nobody is terperangkap, terperangkap in the banjir. So if you have any problem related to flood that might affect your study this week, just let me know. Maybe I can inform somebody up there, but don't put too much hope because I also not sure, because there are so many even lecturers are still stuck in their homes due to flood. But anyway, so today we are going to discuss your quiz 1, 2, 3, and what I want you to do is I want you to check your answer, and if you think you answered correctly but your marks is not reflected with the answer that you give, please let me know, because we need to correct, we need to do some correction with your marks before we finalize the marks for your midterm. Okay, so question for quiz 1. So quiz 1, an active suspension system is used to improve the ride comfort of a vehicle. The system consists of a hydraulic cylinder attached in parallel with the conventional spring damper suspension. The typical setup for an active suspension system is shown in figure 1. One of the goals to improve ride comfort is by minimizing the sprung mass vertical acceleration ZS double dot. Whenever the vehicle exposed to any vibration generated by uneven road surface ZR, the disturbance forces will be transferred to the unsprung mass, and then to the sprung mass through the suspension system. A controller can be designed to better compensate the disturbance forces that pass through the suspension system. So question A suggests a suitable sensor to measure the output of the suspension system. So for question A, before you can suggest a sensor, so you need to know what is the output for this system. So the question already described what the system actually measures. So here in this paragraph here, in this sentence here, one of the goals to improve ride comfort is by minimizing the sprung mass vertical acceleration. So actually the system measure this sprung mass acceleration, vertical acceleration. So obviously the output is the sprung mass acceleration. So to measure acceleration, you can either put accelerometer. So if you answer accelerometer, your answer is correct. Another possible answer is if you answer vibration sensor or distance measurement sensor or gyroscope, so you get 1 mark. If you don't answer anything, 0 marks. Okay, so when you know the output, so the output just now is the the vertical mass acceleration. So output is ZS double dot. So for question B, draw a closed loop control system block diagram that can be designed to compensate the disturbance acting on the suspension system. Your block diagram must contain the controller, hydraulic actuator, the spring damper system, the disturbance, and the sensor. So we know now that the output is ZS double dot. So the input can be either the same thing, yeah, displacement or acceleration that you desire, okay, what you want the system to accelerate. So maybe we can start by drawing the block diagram. So make sure that it is a closed loop. So for a closed loop block diagram, you must have the summing junction and also feedback. Okay. So if you forgot to draw summing junction, you might lose marks for your quiz number 1. So if you draw without the closed loop feedback here, you might lose marks as well. Or even if you draw something else, like in your project. So some of you in project maybe draw a closed loop system. I don't know where did you get the block diagram? Maybe from internet. So if you don't have this summing junction and feedback arrow here, you will lose marks for the block diagram. So we can start drawing by putting an input. So input, maybe input ZS, or input acceleration or input displacement. And then going into a summing junction. And then the question already gave you what blocks to put or to include in your block diagram. So you have controller, hydraulic actuator, and spring damper system. So just draw. So next one is controller. So I think you can either write a controller here or just put symbol GC, okay, from the instruction given. So you can just put GC or you can write controller. And then after controller, you have the hydraulic actuator. And then you have something else first, the disturbance. Okay, so your disturbance will affect the spring damper system. Okay, so it is described here. The disturbance forces will be transferred to the unsprung mass and then to the sprung mass through suspension system. So the disturbance will affect the spring damper system. So before spring damper system is your disturbance. Then after that, you put the block for disturbance and then output. So we need to add the sensor. So sensor is at your feedback. Okay, so make sure that you have some junction here. and a summing junction to show that the disturbance is coming into the system. I think if you don't put summing junction here, you might lose marks as well. So check if you don't put the disturbance. I mean, if you don't put summing junction here, maybe if your marks is lower, then maybe because you don't put summing junction to represent the incoming disturbance. And also make sure that the feedback loop is coming from here. Maybe some of you draw it from the box. Okay, so sometimes you might lose marks here, if you draw the feedback loop coming from the box. Okay. Okay, so if you have all of this, then you get 3 marks. Any question before we proceed to quiz number 2?
So, kalau nanti kalau nak betulkan WhatsApp saya ke macam mana?
Apa nak ada nak adjust markah ke?
Saya rasa saya tak tanda saya punya soalan 2 B.
Okey, tanya Dr. Cik Rosmazi.
Oh,
Tapi
dia yang tanda.
sekejap tapi dalam kalam awak check hantar tak?
Hantar dia bagi markah 25 je. Tapi saya punya yang block diagram ni lebih kurang sebenarnya.
Oh, ya ke? Layan je lah 25. Awak message dia kot. Message dia.
Okay, sir.
Then beritahu lah. Okay. Okay. Any question? Any more question? Okay, so I hope all of you can understand now how to draw block diagram for closed loop system. Okay, this is similar to your project. So some of you, when I ask closed loop system, you don't have this summing junction. Okay, most of you forgot to draw summing junction. So you assume that the controller is the summing junction, something like this. So this is wrong because summing junction has its function. So I already taught this in lecture block diagram, okay? Reduction of block diagram. So please don't make mistake on this because this is lecture number 1. Very simple question because I think during final later, this is the only question that you can answer that I think you can confidently answer correctly. The other question might be difficult, okay, because it involves calculation. So question regarding drawing block diagram is something that you can get full mark, okay, not full mark, even if not full mark, maybe separuh ke. Okay, so please make sure you have all of the things correct, okay, like summing junction, the feedback loop, and the components, okay, the blocks. Some of you still confused what are plant. Some of you confused what are controllers. Even put sensor like temperature, a thermometer as a controller, and a controller you put as a plant. So make sure you know what is plant, what is controller, what is sensor, because this is the basic knowledge in automatic control. Maybe the calculation part is already detailed, okay, detailed already. But the drawing block diagram, please make sure you know, okay, the difference between controller, sensor, subsystem, plant, and so on. Okay, so now let's look at quiz number 2. Okay, so for quiz number 2, I think most of you are surprised because you get low marks. Okay, So don't worry because actually we key in the marks wrongly. So we will correct the marking after this. Okay, so we just realized, okay, we key in the marks wrongly. Okay, so let's look at this question. Okay, figure 1 shows the suspension system of quiz 1. Okay, so we go back to quiz number 1, same suspension system, which hopefully most of you still remember. Okay, ni masa quiz hari tu tak remember kot, sekarang dah remember. Taking the actuating force FA generated by the hydraulic actuator as the input. So this FA is your input, and assume that there are no disturbance forces acting to the system, making ZR equals 0. So here note that input force FA is acting on both mass. Okay, so this FA not only acting on one mass, but it acting on both of the spring and unsprung mass. So find the equation of motion for both sprung and unsprung masses. Okay, so let's do this. Okay, so before we go into finding the equation, we need to follow the step-by-step that I taught you back in maybe week number 2 or week number 3. So let's revise. So the step to uh, model system. So we have 4 steps, okay? So step 1, list input output. Then number 2, we draw the free body diagram. And then number 3, we write the equation of motion. And then number 4, we find the transfer function. Okay, so question A wants you to find the equation of motion, meaning until number 3, okay, until step number 3. So let's list the input output. So number 1, input is FA, and the output, because we want to measure the displacement or acceleration and velocity, we can measure the either ZS or ZU. Okay, so ZR is assume 0. Okay, the question says ZR equals 0. So output can be ZS or ZU. Okay, then we draw the free body diagram. So as I said last time, make sure that your free body diagram is correct. Okay, so the most important part is the free body diagram. If it is not correct, then the rest of the answer will be incorrect as well. So please make sure free body diagram is correct. So let's go to sprung mass. Okay, the sprung mass. Okay, so on the sprung mass, the motion is assumed upward as positive. So any forces by the spring or damper will be acting downwards. Okay, so we have Ks and Bs, Ks from spring and Bs from the damper connected to Ms. So we have Ks Zs, and we have Bs Zs dot, and also we have the inertia Ms Zs double dot. And then the spring and damper also connected with Mu. So we need to consider the force by Mu. So you can either combine the force together, or you can separate them. Okay, so I prefer separate. So Ks mu. So the force from mu will be acting upward. So Ks mu and Bs, Ks Zu. Okay, Ks Zu and Bs Zu dot. And then we have the actuating force Fa. So you can assume Fa is something like pushing both of the mass away from each other. So if it is pushing away, then one of the force will act upward, and the other will act downward. Okay. So if it is bringing the two mass together, then one will pull, and the other will be pulled upward. Okay, pull downward and upward. So if one of the force Fa on the sprung mass, we assume going upward, then the force on unsprung mass will go downward. Okay, because the hint already give that the force acting on both of the mass. Okay, so it's not only on one mass, but it's on both of the mass. So here we assume Fa acting on ms by pushing it upward. So we have one upward force Fa here. Then we can write the equation of motion. So we have ms zs double dot plus bs zs minus zu dot plus ks zs minus zu equals Fa. Okay, so this is in time domain. You can write as like this, or if you look at question B, later you need to generate the matrix for the Laplace equation. So you can continue writing in frequency domain. It should be correct. Okay, so if I write in frequency domain, I will get ms s squared plus bs s plus ks zs minus bss plus ks zu equals Fa. Okay, so this is equation 1. And now let's look at the second mass. So again, on the second mass, we have spring Ks, spring Bs, damper Bs, and spring Kt. So Kt, if we assume Zr equals 0, then it is something like connected to a wall, okay, or to a floor, because Zr is not moving, okay, or Zr is 0. So we assume that Kt is connected to a floor. So we have two spring and one damper. So first spring Ks, so Ks Zu, and then Kt Zu, and then Bs Zu dot, and the inertia Mu Zu double dot. And then we have the effect of Ks and Bs from sprung mass or from Ms. So we have Ks Zs and Bs Zs dot. And then we have the actuating force. So from Ms, from the sprung mass, it's acting upward. So on Mu for unsprung mass, FA will act downward. Okay, so downward, FA. Now we have all of the forces, then we can write the equation of motion. So mu zu double dot plus bs zu dot minus zs dot plus ks zu minus zs plus kt zu equals minus fa or plus fa equals 0. So if you bring to the other side, then it becomes minus fa. Then you can write in Laplace or in frequency domain. So you get negative bss plus ks zs plus mu s squared plus bss plus ks plus kt times zu equals minus fa. So this is equation number 2. Okay, so if you have the equation similar to what I wrote here, then you get 2 marks. Okay, now we can write the equation of motion in matrix. So we have 2 equations here. So we can write in matrix form. So in matrix form, so first we write everything on the first column. We write all the terms that relate to zs. So here we have ms s squared plus bss plus ks, and then on the second equation we have negative bss plus ks. And then on the second column, the first equation we have negative bss plus ks, and then on the second equation we have mu s squared plus bs s plus ks plus kt. Okay, close the equation. Multiplied by zs zu equals fa minus fa. Okay, so if you have this as your matrix, then you get 2 marks. Then lastly, the question C asks for the transfer function G1 Zs over Fa and G2 Zu over Fa. So leave your final answer in terms of Ms, Mu, Ks, Bs, Kt, and Fa. So you don't need to solve. So let's try to find. So you can use Cramer's rule. So first one, to find G1. So G1 is Zs over Fa. So Zs over Fa, meaning that the question, meaning that you need to solve the matrix on the first column or for Zs. So to solve that, you replace the first column with Fa negative Fa, find the determinant divided by determinant of the original matrix. So Fa negative Fa Okay, so ni saya malas. So, ni A, ni B. Tapi korang tulislah in full, okay? Or maybe to make it better. A, B, C, D. Senang sikit. Divided by the determinant of A, B, C, D. So the answer given to me, you need to simplify. Okay, 2 by 2 matrix, simplify lah. Okay. And then you, after you simplify, you get, you just bring FA to the other side to get ZS. Okay, so this one is ZS, is ZS. Then bring FA to the other side, you get ZS over FA. So maybe you don't get full mark because you don't simplify. So if you look at the question, 8 marks. So I think this is 4 marks, simplified another, this is 2 marks, simplified another 2 marks. So repeat for G2, 4 marks, okay, for G2. Okay, so G2, ZU over FA. So Z2 is the same determinant, but now you need to replace the column FA and negative FA on the second column of the big matrix. Okay. So simplified, you get 8 marks. Okay. Any question before we proceed to the next quiz? Yep.
Sir,
Hmm.
kalau saya buat yang ZU saja duduk kat atas, boleh ke sir?
Macam mana?
Yang saya buat kan ZS dengan ZU. ZS sebelah atas. Bawah tu ZU kan? Kalau terbalik?
Kalau terbalik, make sure dia,
terbalik.
kalau terbalik, make sure dia punya final answer sama. Kalau final answer sama, okay lah. Kalau terbalik, mungkin awak punya equation ni ZS, ZU, ni saya punya ZS, ZU. So maybe awak punya ZU, ZS. Kalau ZU, ZS, dia akan jadi MUS squared plus BS S plus KS plus KT. Sekejap. So dia punya matrix akan jadi macam ni. Equals negative FA, FA. Kalau macam ni betul. Sama juga.
Lepas tu masa yang kita nak gantikan SA dengan negatif SA dalam A dengan C tu, dekat situ juga ke sir? Dia kena dekat belah BD.
Kalau macam ni, nak cari ZU, FA, FA ni dekat first column. Kalau yang ni. So nak cari ZU, then ZU is negative FA, FA, BD. BD ni BD, ni AC. AC, BD. Macam ni. So dia terbalik dari ZS ni. ZS ni negatif kat bawah. Ada beza, ada beza. Negatif kat bawah dengan BD dia terbalik. Faham kot?
Faham. Betul.
Tapi markah yang quiz 2 tu nanti kita akan betulkan balik. Jangan risau. Tu nak bagi korang sedih. Tu je. Okay, any question before we go to third quiz? Okay, so I hope you know by now how to find the matrix and find the transfer function. So make sure that when in final exam later, you make sure that you get the free body diagram correct. If your free body diagram is incorrect, then sampai habis salah, okay? So make sure that the first part here is correct, then barulah fikir pasal nak susun dalam matrix semua tu. Okay, so let's look at quiz number 3. Okay, so quiz number 3 is a no-brainer quiz. Patutnya boleh dapat full mark, okay? So let's look at the answer. Okay, so saya pun tak ingat, kita tengok nota, lupa dah macam mana benda ni. Okay, so question 1. So when transfer function is 25 divided by s squared plus 10s plus 25. So you can find the pole. So to find the pole, you can just use quadratic equation formula. So if you don't know, if you malas, you can just use calculator. So calculator, you get so the pole is -5, okay? So we get poles equals -5 minus 5, ada 2 kali. Okay, so you get 2 real roots, 2 equal real roots, okay? So if it's 2 equal real roots, then you can sketch in S plane. So J omega sigma. So here -5. So lukis 2 kali. Okay. So in your project, some of you draw S plane, label -5, but don't have the cross. So markah hilang lah, tak ada cross. So the cross here represent poles, okay? So always remember, cross represent poles. If you want to use a different symbol, make sure you put, bagi tahu lah. If you don't want to use cross, maybe you want to use triangle, okay? Bagi tahu triangle represent poles. Okay, siapa suruh guna simbol lain? So kalau guna simbol lain, beritahu ni apa benda. So kita biasa guna cross, okay? So cross represent poles. So some of you in project part 1, project 1, part 2, you don't put cross in your S plane. So hilang lah, dapat satu markah je. And then the question asks the general response of the GS of the system. So if you look at slide, it's critically damped. So critically damped. And then lastly, sketch the general time response. So if you look in lecture notes, so the graph of the time response. So under step input, okay, so under step input, so it should look like this. Okay, so if you get all of these 3 correct, you get 3 marks here. Okay, ada 12 markah. And then we go to question number 2, the transfer function number 2. So GS equals 7 divided by S squared plus 7. So if you use calculator, you get poles equals square root of 7 J plus minus. Okay, so plus minus square root of J, square root of 7 J. So if you sketch in S-plane, so it's located here and here. So square root 7 and minus square root 7. And then from lecture notes, it's undamped system. Okay, so tak payah kira apa-apa pun. And then lastly, you sketch the time response under step input. You will get a marginally stable system. Okay, a system that keeps oscillate until even though the time is infinity, reaching infinity. And then the third one, so you need to use calculator for this, or you can use by hand if you like. So if you use calculator, you get poles equals -2 and -6. Then you can sketch on S-plane. So here it's -2 cross and -6 cross. So from lecture notes, it's over them. And the time response, the sketch of time response, it's something similar to critically damped. Tak ada damping, tak ada overshoot, sorry. Okay, and then lastly, the fourth one. Okay, so here also 3 marks. And then lastly, GS equals 8 divided by S squared plus 4S plus 8. So again, use calculator. So you get poles equals -2 plus -2J. So here, if you sketch on S-plane, so this is 2, this is -2, and -2, so it's somewhere here. So this is under them. And then the time response, you have some overshoot, okay? And this is also 3 marks. Okay, so the last one here, there is no marks here. Here for this last one here, this is just to test you on whether you are smart or not. Okay, so the last one, find the poles. So you get poles equals 1.46 and -5.46. So if you sketch on S-plane, it's here -5.46 and here 1.46. So the general response, there is no general response here. Why? Because this is an unstable system. Okay, because you have one pole on right hand side. So when a system has one pole on right hand side, so this system is unstable. So maybe the response, the time response, it increasing, something like that. Okay, so there is no general response. It's an unstable system. Okay, and here this question has no marks. Okay, this is just to test whether you know that this is unstable system. And so additional 4 marks if the table has a system that you think is an underdam. So we have underdam the fourth one here, the fourth transfer function. Then find the overshoot and settling time. So you need to check the formula for overshoot and settling time. So overshoot. So before you can find overshoot and settling time, we need to find the damping ratio and also natural frequency. So let's find the natural frequency. So natural frequency equals, so natural frequency is when the middle part of the denominator becomes 0. So you get s squared plus 8 equals 0. So you get s equals square root of minus 8. So you get square root 8 j plus minus equals j omega n. So omega n is square root 8. And then when you get omega, you can find the damping ratio. So damping ratio equals 4 divided by square root 8 times 2. So you get 2 over square root 8. And then we can use the formula for overshoot. So percent overshoot. This one, calculate yourself. Okay, so you just plug in the number and then settling time Ts equals 4 over omega damping ratio omega n. So if I have all for this omega n, damping ratio, percent overshoot, and Ts, you get 4 marks. Okay, so for this question, if you think you deserve more marks, please contact Cik Rosmazi. Okay. Okay, that's all for quizzes. Any question before we end this lecture?
Sir, nak tanya.
Yes.
Untuk discussion ni, sir ada upload dalam YouTube tak?
Ada.
Okay. Thank you, sir.
Okay, so if you have no more question, then see you this Wednesday, inshallah. Assalamualaikum and goodbye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.